Hello everyone, today I'm going to be teaching you how to do bivariable analysis in R. And this is our Q4D lab. You can visit our website. So as I mentioned, we'll be doing bivariable analysis in R. And this is the part 1 of our video. We have 3 objectives. 1 is reading data into R. 2 is differentiating variable types. And our last objective is reformatting variables of interest. So let's begin with reading data into R. And we'll open our strip into R for us to do this. So reading data in R is quite simple. We want to set up our working directory. So here we choose directory. This is just us telling R where our data set is saved. So mine is in the desktop in a folder called Q4D directory 2. So once we do this, we will see this in the console. We can either copy this and paste it directly in our strip, or we can run it from here. The next step in reading data is naming that data in R. So we want to name this our diabetes analysis, since we are dealing with our diabetes data set. And then we want to use the read.csv function, since we are dealing with a CSV file. And then tab, and then select the data set we'll be using. And for best practice, we use the header equals true function. This helps R to recognize the first row as the variable instead of a response. And then we can explore the dimension of the data using the dim function. This tells us the amount of rows or in columns in the data. Next, we use the head function. So the head function gives us the first 6 rows of responses in a data set. So you can see we include pregnancy, glucose, blood pressure, body mass index. So that is how we read data. Our second objective is differentiating variable types. And this is very important when we are doing bivariable analysis. So there are 2 types of variables. We have what we call continuous and then categorical variable. So continuous variable are numeric variables. These are variables that basically takes on real value. For example, the height of individuals attending a basketball game, the weight of a pregnant woman, or the blood pressure of a pregnant woman during her pregnancy. These are all continuous variables. Then categorical variables are variables that take on discrete values, or think of the options of a multiple choice questions. It can be divided into groups. For example, gender, you have male or female. Disease status, you have yes or no. So these are categorical variables. And it's important to know this. So the data set we'll be dealing with today is the diabetes data set. And there are 2 variables of interest that we want to focus on: body mass index and disease status. That is whether a person has or diabetes or not. This data set can be accessed on Cargo, or it can also be accessed on our Q4D portal. So as we discussed, we say continuous variable and numeric variable. So in this data set, we can see here that BMI has numeric values, therefore it's a continuous variable. On the other hand, outcome we see 2 responses, either 1 or 0 representing yes or no. So this variable is categorical. So our goal here now is, our third objective here is to reformat the BMI variable into a categorical variable so that we can use it in the bivariable analysis. How do we do this? So for us to reformat a variable, we use the which function in arrow. And so go back to our strip. Let us first of all explore the data to make sure that the BMI variable is a continuous variable and the outcome variable is or categorical variable. And we can do this in arrow using the class function. So first I use the class function BMI, and we can see that it's a numeric variable. It's okay. We use the same class function on the outcome variable. Okay, we see that it's an integer. So what do we want to do here? We want to coerce this outcome variable to become a factor. So this is the code we use. So coercing the variable in a factor is you telling arrow to recognize the responses for outcome as discrete or values instead of as an integer or numbers or just numbers. So when we run the class function, we see that BMI now is now a factor. Outcome is now a factor, sorry, and it is what we want. Now that we have confirmed that our variables are continuous and categorical, we want to reformat the BMI variable to become a categorical variable. So we do this by using the which function in arrow. So why do we want to recategorize or to categorize BMI variable? According to CDC standard, all BMI reading that fall below 18.5 is considered as underweight. Those that fall between the range 18.5 to less than 25 are healthy, while those that are greater than 25 but less than 30 is considered overweight, and anything above 30 is obese. So this is the standard we are going to use to categorize the BMI variable. Please remember this. So now, let's run the here function. We see that our BMI here is continuous, and we want to make this variable categorical. So what we want to do is to create a space in arrow that will accommodate our new variable or new categorical variable. So let's name this risk factors. So this is a risk factor for diabetes. Then we use rep or create space in the data, and then we want to go back to the dimension and use our total or rows, which have 768. By doing this, we have created a new space in the data set, and we're going to be using the new space along with the which function to categorize our BMI variable. So what we're seeing here is which or diabetes data analysis BMR is, first of all, we say less than 18.5. So any BMI, we tell our any BMI variable that is less than 18.5 should be renamed underweight. And then we can do the same for overweight, healthy, and that of obese. Run the same function. So we can see here that less than 18 will be called underweight, between 18.5 to less than 25 will be healthy, while 25 to less than 30 is overweight, and greater than or equal to 30 is obese. Then we can now run this. Once we do this, we want to run the table function. Since we are dealing with the categorical variable now, we want to run the table function. So when we run the table function, we see that for healthy we have 102, obese 472 responses, overweight 179, underweight 15. So our BMI variable now is a categorical variable. And we can also run the prop table to get the percentages of each level. So this is how we reformat our data into array. It's quite simple. We now move on to our bivariable analysis. We now move to, that is for us to conduct the bivariable test. Now for us to conduct the bivariable, I'm encouraging you to follow our social media platforms on YouTube, Facebook, and LinkedIn for part 2 of this video. Thank you so much for watching. See you in the next video.